Dear students, in this video, we are going to discuss one more important antenna called as helical antenna. So, what is the special feature of this helical antenna? The special feature of this helical antenna is it will produce circular polarized wave. Okay, circular polarization is achieved by this helical antenna. So this is the main advantage of the helical antenna. So where we are supposed to use this circular polarization. So in all mobile communications, we need circular polarization. So circular polarization is achieved by generally loop antenna as well as helical antenna. So we will see what is the construction and everything. Okay, introduction to the helical antenna. Okay, so see here is nothing but the helical antenna means. Okay, so let us take a bar. Okay, if we take a simple wire and if we unwound like this, okay, and if you remove this bar, then the wire, conducting wire, will looks like helix. Means this is nothing but a helix. Okay, so if you wound a wire on a conducting material like this, then the helical antenna comes into picture. So this is the structure of the helical antenna. So this is the structure of the helical antenna. So helical antenna is a type of antenna that is used for designed using conducting wire, and it is constructed in the shape of helix. Okay, so these antennas are considered the simple antennas and are widely used for very high and ultra high frequency of operations. Okay, so where they are used for extraterrestrial communications and satellite relays. So the mode of operation is from 300 megahertz to 3 gigahertz. So as I told that the main application of the helical antenna is it can produce circular polarized wave. Okay, so generally helical antenna will operate in two modes. One is in normal mode and other one is axial mode. So we will discuss briefly what is meant by this normal mode and what is meant by this axial mode in coming classes. Okay, so first we will discuss the construction of the helical antenna. Helical antenna. So this is the structure. Okay, so here this is our helix. This is our helix. Okay, so what is this? Yes is nothing but separation. So for example, if this is my helix. Okay, so S is the separation distance between turns. So this is one turn. Okay, this is second turn. This is first turn. This is second turn. Okay, so here N is used to represent number of turns. N is used to represent number of turns. Some helix may consist of 10 turns, some helix antenna, helical antenna may consist of 8 turns. Here N indicates number of turns, and S, what is this S? S is the spacing. S is the spacing. Okay, so this is your helical antenna. How will you excite this helical antenna? So you will excite this helical antenna, you are providing feeding through a coaxial cable. So this is a coaxial cable. If you provide here feeding, okay, so the current rotates in this helix and produces and it will operate at different frequencies. Okay, so this is the basic structure of helical antenna. This is the basic structure. Okay, so see here this S where here S is spacing between the antenna. Okay, so a helical antenna is constructed using a conducting wire. Generally, a thick wire is wound in the form of helix and is used in conjunction with a metallic plate. Okay, so the excitation of helical antenna is provided by using coaxial transmission line. So here using this coaxial transmission line, we can excite the helical antenna. Okay, so for example, so this is one turn. These are turns. Here, how many turns are there? 1, 2, 3, 4 turns are there. For example, here what is this S? S is nothing but spacing between the turns. S is nothing but spacing between the turns. And if you observe here, so this is nothing but D is the diameter from here to here. So if you consider this as a total circle, the D is the diameter, and here C is equal to pi d, where C is the circumference. Okay, so if C is the circumference. Okay, so for example, if we unroll, okay, if we unroll one turn of the helix, if we unroll, so this is one turn. Okay, so if you unroll one turn of the helix of the surface, then the circumference C, then the circumference C, then the circumference C, this is circumference means nothing but circumference C, and the spacing between the turns S, the spacing between the turns is represented with S, C is circumference, S is spacing. And the turn length is represented with, total turn length is represented with L. And N indicates number of turns. N indicates number of turns. And so it is given by an pitch angle. Okay, so for example, if I unroll one turn length, okay, if I unroll one turn length, so this can be drawn like this. This can be drawn like this. So this is called alpha. Alpha is called as pitch angle. Alpha is called as pitch angle. Okay, so what is this pitch angle? Pitch angle is defined as the angle between a line tangential to the helix wire and the plane normal to the axis of helix. Okay, so pitch angle alpha is defined as the angle between a line tangential to a helix wire and the plane normal to the axis of helix. Okay, so that is the definition of the pitch angle. So alpha, so here this S, if I unturn, okay, so the separation S is the separation distance and this is total circumference. Okay, so C is equal to, generally circumference of a circle is 2 pi r. In the place of 2r, a diameter is 2 times of radius. So C is equal to, I can write it as pi d. Okay, so in this, so if I apply tan alpha, if I apply tan alpha, if I apply tan alpha, so what is the formula for tan alpha? So opposite side by adjacent side by pi d, and this is total length L. Okay, from here to here, this is total length L. Okay, so from this, what is the value of alpha? So alpha is equal to tan inverse of S by pi d. Okay, so from this triangle, what is the formula for the hypotenuse? Hypotenuse is equal to root of S square plus C square. So that is nothing but L is equal to root of S square plus C means, what is the value of C? Is pi d whole square. Okay, means very important thing. So I have told that the antenna is operating in, the helical antenna will operate in two modes, either in normal mode or in helical mode. Helical mode. So in which mode it want to operate, it depends upon these parameters. One is spacing, one is the circumference, and is the spacing and circumference. So the mode of radiation of an antenna depends upon the mode of radiation of an antenna depends upon the diameter of the helix. Diameter of the helix D, diameter of the helix D, and the spacing between the turns, and spacing between the turns. Spacing between the turns, I have already told. So the pitch angle alpha is defined as the angle between a line tangential to the helix wire and the plane normal to the axis of helix. Okay, so in the coming video, we will discuss what is meant by this normal mode, when will be the antenna is said to be operating in the normal mode, and when will be the antenna is said to be operating in the helical mode. Helical mode. So just I will give a simple description regarding this normal mode and helical mode. The next videos we will discuss briefly. So what is meant by this normal mode? Okay, so in normal mode, let us consider this is our helical antenna. So this is my helical antenna. So let us consider this is my axis of the helix. This is my axis of the helix. Okay. So here the diameter of the helix is very less than lambda. Okay. So similarly, other mode is axial mode. Okay. Here the helix length is a little bit more when compared to the dimensions. Okay, here the D is almost equal to the dimensions of the helix are almost equal to the one wavelength. Okay, so here also I will consider. So let us consider this is axis of the helix. Okay, so what is the difference between this normal mode and axial mode. In normal mode, in normal mode, here here this is the axis of the helix, axis of helix. This is also the axis of helix. This is also the axis of. In normal mode, the radiation is perpendicular to the axis of helix. The radiation is perpendicular to the axis of helix. Whereas in axial mode, the radiation is along the axis. The radiation is along the axis. So this is the basic operation of helical antenna, either in normal mode or axial. Okay, so we will discuss briefly that in the next videos.